Number 6 on 10.3, let's write the standard form equation of a circle that passes through the given point and the center at 0, 0. So there's the center, and it passes through the point 2, 1. So I need to know the length of this black line. In order to find the length of a distance of a diagonal line, we could make a right triangle, or we could use the distance formula. But the distance, or the difference in the x's, is going to be 2. That's this length. And the distance between the y's is going to be 1. So in the distance formula, I square root the difference in the x's squared plus the difference in the y's squared. So I get the square root of 5. And I plug that into this formula. Again, this is the distance, which is now the radius. It's the radius of our circle. I could sketch a little circle through that. So now I plug the square root of 5 in here. So the square root of 5 squared is just 5. So I have x squared plus y squared equals 5. Over here, maybe I'm not going to make a picture this time. They don't say to make a picture, so sometimes it's super helpful. But here, I think I could just do this algebraically. So my difference, or my distance in the x's, is 4, so I'm going to square that. My distance between the y coordinates is 5, so I'm going to square that. Add those answers together and square root. So you get 16 plus 25, which is 41. So that value now goes in place of the R. I get a free brat. Dang, talk about perks of teaching. What? So, x squared plus y squared equals, this goes in place of the length of my radius. Square root of 41 squared, you're probably like, dude, the squares and the square roots cancel out, so the best answer is x squared plus y squared equals 41. All right. Woo! Write a tangent line. A tangent, well, let me graph this first. So write the equation of a line that is tangent to the circle, centered at 0, 0, and at the following point. So circle centers at 0, 0. It goes through the point -6, -3. Ooh, that was a weird, that would be -6. This would be down 3. So it goes through right there. So my circle goes through there, kind of like we were sketching on a couple of the problems over there. It's a bad circle. Definitely not centered around 0, 0. But anyway, we know it goes to this point, and now we want a tangent line to it. So I'm going to sketch my radius like we were doing before. This is the radius. The tangent is going to be perpendicular to it, so it's going to meet at a 90-degree angle. This looks like about 90 degrees. Like it should make an L. It should make a letter L out, and then you keep going. Tangent means the line that intersects the circle just once. And if I would have angled that any other way, if I would have sloped it any other way, it either wouldn't touch the circle or it would intersect twice. It's a very precise slope or angle that you need. We can calculate the angle of the tangent line, but first what we need to do is calculate the angle or the slope of the radius. So the radius is going to be, so now I'm not thinking distance of the radius, but I will need to know the distance of, or the change in the x's and the y's. So the change in the y's here is 3. It's 3 steps up, and the change in the x's is 6. It's 6 steps over. So slope is rise over run. So the slope of my radius is 3 over 6, rise over run, which is 1/2. So the slope of my r, which is radius, is 1/2. The slope of your tangent is the opposite reciprocal of that. So the reciprocal means flip the numbers over, 2 over 1, which is just 2. But then the opposite, since this is positive, this needs to be a negative. And if you look at my tangent line, that's a negative slope, right, folks? And if you look at the slope of my red line, that's a positive slope. They need to be opposite slopes and reciprocals, flipping the rise and the run. Now I want an equation of this blue line. So we'd recommend using point slope form, but there's many ways you can do it, and I don't care how you do it as long as you show your work. Oops. So you plug in your y coordinate for y1, plug in your slope for m, plug in your x coordinate for x1, and then we work from there. So here's your x1 and y1. Here's the point that this slope goes through is right there. So y minus -3, which is the same as adding a positive 3. Slope is -2. -2 over 1, but I don't need that over 1. And then x minus -6, which is the same as x plus a positive 6, adding the opposite. Then you distribute. Then you solve for y. Again, if you want to use slope-intercept form and do it that way, I don't care. But that's the answer you should get. That is the equation of the blue line. We already knew it had a slope of -2, but it turns out it crosses the y-axis. The y-intercept is -15, which I wouldn't trust my tick marks there. Let's make a good sketch of number 9. So we need a tangent line of the circle that goes through the point 4, -8, and the tangent line hits the circle and is tangent at that point. Oh, not the best circle ever. Wow, that's really bad. That's super bad. All right. So draw your radius. That's my radius. I need to know the slope m of the radius. So that's not Mr., it's m sub r. Slope m of r, the radius. So I need to figure out my rise and my run. So here's my rise. I actually go down 8, and my run is over 4 because this point's at 4, -8. So the slope is -8 over 4, which is the same as -2 over 1. So that means, again, the tangent line looks like this. It's perpendicular. So what makes an L with the red line? It's that. So I can see that it's a positively sloped line, which we're surprised about talking about the last tangent line. And then I know it's not as steep. Like if I have to hike up this red line, oh, that's a steep hike. This is not as steep, so the slope's not as steep. So the slope of the tangent line is going to be, again, the opposite reciprocal. So the negative goes to a positive. The 1 over 2, the 2 over 1 becomes a 1 over 2. So the slope is a positive 1/2. So I know the slope of that tangent line. I know the tangent line goes through the point 4, -8. So now I can plug things in. Y minus -8 equals the slope times x minus 4. Chop, chop right here. We get y equals 1/2 x minus 2 when we distribute. And now we subtract. Oops, I didn't copy that very well. It's y plus 8. I missed the plus 8. So now we subtract 8. Distribute first. Get y by itself second. So y equals 1/2 x minus 10. Boom. That's the slope, or that's the equation of the tangent line.